everyone, it's Hannah. Today I will be showing you how to calculate an LC50, which stands for Lethal Concentration 50%. This helps predict the environmental hazard and safety of many different chemical products. My father's team does chemical testing on shrimp and other small organisms. Then my dad takes the percentage of dead organisms from a test and plots them on a graph called the dose-response curve. The dose-response curve is a relationship between the concentration of a given chemical and the response of the organisms, which is mortality or survival. The Boltzmann equation, which we will be focusing on today, is one equation that can be used to calculate an LC50. It is y equals 1 over 1 plus e to the h minus x over slope power. H is the same as the LC50 because H stands for half or 50% of the maximum responses from the organisms. So let's get started. The sample values that we're going to be using today in the formula are 71.4 for H, or the LC50, 60 for X, and 6.83 for the slope. The exponential fraction for the first thing we need to simplify. After that, take a look at E. E is just like pi because it's an irrational number. But when solving an equation, it can only be accompanied by an exponent, hence the reason it's called E. So to find E by itself, take your calculator, press the button that says e to the x power, and calculate e to the first power. The value for E is 2.718 depending on where you terminate it. Then obviously replace the E with 2.718 and solve that with the exponent. Also, your fraction in the denominator, which is also your exponent for E, should end up being 1.67. Now calculate 2.718 to the 1.67th power. Your equation should now look like y equals 1 over 1 plus 5.31. Then just add up the 1 and the 5.31 in the denominator and divide the numerator by the denominator. Voila! Your answer should be 0.16 or 16% of the mortality of the organisms. Here is an example of the dose-response curve. The Boltzmann equation uses the 50% of mortality and the slope as parameters to find the curve that best fits the data plotted. Anyways, hope you enjoyed the video. Have a great day. Bye!